Okay. Finally, what we're going to wrap up with is we're going to look at where we actually want to see how much of a loan or how expensive of a house we can buy based on knowing how much we could pay each month, knowing the interest rate, and knowing how long we would be able to pay for. Um, in order to do this, we got to do three things. The first is figure out our number of payments. After doing that, we got to convert our yearly interest rate of 3.5% to a monthly interest rate. And then once we have the number of payments and our monthly interest rate, and we know our payment amount that we can make, we would have all the variables we need to plug into our amortization formula to figure out how big of a loan we could take out. Now, the only thing is, with the last part of plugging everything into the amortization formula, I've done that before for you and showing you the same thing, how to simplify an equation. I could do it again, but I would rather not do that and give you the answer just so you can do it yourself, just to make sure you know how to simplify the equation. And if you're struggling with it, go back to one of the previous videos where I simplify um, the amortization formula by, just following our order of operations, doing one thing at a time, looking inside the brackets, looking inside the parentheses, simplify, simplify, simplify until you obtain the answer. Okay, well, the first thing is the number of payments. That's going to be the years of the loan times 12, because there's 12 months in a year, 12 payments. Every month we make a payment. 30 years, 12 payments a year, 360 payments we got to make. Sorry, got to readjust. Okay, the second thing we need to do is convert our annual interest rate to a monthly interest rate. The formula was 1 plus the annual interest rate is equal to 1 plus the monthly interest rate raised to the 12th power. We substitute our 3.5% interest rate in, convert it to a decimal, which is 0.035. So what we have is 1.035 is equal to 1 plus the monthly interest rate raised to the 12th power. Now, we have that variable, which is what we're looking for, the monthly interest rate, but there's an exponent outside of it. So we got to get rid of that exponent to be able to eventually isolate the variable. So since the exponent is 12, we got to raise both sides of the equation to the 1/12th power. So 1.035 raised to the 1/12th power, and then everything on this right side, the 1 plus the monthly interest rate to the 12th power, that all gets raised to the 1/12th. And the 12 raised to the 1/12th cancels out, because when you raise an exponent to an exponent, you multiply them. So when you multiply 12 times 1 over 12, it just becomes a 1. That's why we're just left with 1 plus the monthly interest rate on the right side of the equation. On the left side, when we do 1.035 raised to the 1/12th, we get 1.002871. So now all we got to do is subtract 1 from both sides, because we want to get the monthly interest rate all by itself. And we have a 1 plus the monthly interest rate here on the right side. So we got to subtract 1 from the right side. We got to subtract 1 from the left side. So then at the bottom, what we're left with is 0.002871 is equal to the monthly interest rate. And that's the decimal form, so the monthly interest rate would be 0.2871%. And just to make sure if you're sort of in the ballpark, you have 0.28 is very close to 0.3, and 12 times 0.3 would be 3.6. That puts us right around the yearly interest rate of 3.5% that we had. So if you're right around there, it's never going to be exact because you're multiplying numbers times